All right, let's get right into it. Today, we're moving past the simple chatbots we all know. We're going to be looking at the next level of AI. I'm talking about models that can do their own research, use tools, and, actually get stuff done in the real world. So let's break down how all this works.
You've probably felt this before, right? You ask an AI a question, and you get a pretty good answer, but it just feels a little generic. You can tell there's some serious power under the hood, but it also feels kind of trapped, totally disconnected from what's happening right now and unable to really do anything.
So at their core, standard large language models run into three big roadblocks. First, their knowledge is basically frozen in time, from whenever they were trained. Second, they can't reach out and interact with the world to do things. And finally, and this is a big one, they sometimes just make stuff up. We call that hallucination. Today, we're going to unpack the key tech that's being built to solve these exact problems.
Okay, first up, the knowledge problem. How do we give an AI access to information that's current, or private, or super specialized? Well, the answer is this really clever technique called Retrieval Augmented Generation, or RAG for short.
The best way to think about RAG is like this. Instead of the AI just relying on its old training memory, we give it a library card. So before it even tries to answer your question, it can pop over to a private library, full of your company's documents or up-to-the-minute data, find what's most relevant, and then use that information to construct its answer. It sounds simple, but this is a total game changer.
And the benefits here are just huge. With RAG, the AI can use information from today, not from 2 years ago. It can securely work with your private company data, and you don't have to worry about that data getting used for training. And most importantly, because its answers are grounded in real documents, the chance of it just making things up goes way, way down.
So how does this retrieval part actually work? It's a pretty slick 4-step process. First, all your documents get indexed. They're chopped up into smaller chunks and converted into a numerical format called a vector. Then, when you ask a question, your question also gets turned into a vector. Step 3, the system basically plays matchmaker, finding the document vectors that are mathematically most similar to your question's vector. And finally, it feeds those relevant chunks to the LLM along with your original question, giving it all the context it needs to give a super informed, factual answer.
Okay, but wait a second. This brings up a fascinating question, right? We just said the system finds similar text using numbers, vectors. But how in the world can a string of numbers capture the actual meaning of a word like apple?
A vector is basically a mathematical fingerprint for a piece of text. Just imagine this giant multidimensional map of meaning. A vector is like a set of GPS coordinates that places a word or a sentence at a very specific point on that map. Each number inside the vector is like a score for some hidden quality, like how much is this related to fruit, or what's its score for the color red.
This simple example makes it super clear. On that big map of meaning, apple and banana would be plotted really close to each other, right? Their vectors would have similar high scores for things like is food and is edible. But a plane? That would be way off in a totally different part of the map with a completely different set of scores. And how does the system actually measure that closeness? Well, it uses something called cosine similarity. Now, don't worry about the math. The idea itself is incredibly simple. It just looks at the direction the vectors are pointing. If two vectors are pointing in a similar direction on that map of meaning, their concepts are similar. If they're pointing in totally different directions, they're not. It's as simple as that.
Okay, so our AI now has a library. It can know things, but what about doing things? That's the next critical piece of the puzzle. We have to give the AI hands so it can interact with the world, and that's where something called function calling and a protocol named MCP come into play.
Just take a simple, everyday request like this one. A standard LLM just can't answer it. Why? Because its knowledge is static. It has no live connection to weather data. It's completely stuck inside that box. To answer this, the AI needs to be able to connect to an external tool, like a weather API. And this is exactly what function calling is for. It is the bridge that lets a language model connect to the outside world, to other apps, databases, or APIs. In short, it's what lets an AI go from just talking about the world to actually taking action in it.
The process itself is actually really clever. First, the model looks at your request and decides, hey, I need a tool for this. Then it pulls out the key pieces of information, like California and tomorrow. It formats all that into a structured command that the system can understand and run. Once the tool sends back the data, in this case the weather forecast, the LLM uses that fresh new info to give you a perfectly natural conversational answer.
So this is awesome for one tool.
But what happens when your AI needs to use a weather API, and a calendar, and a code repository, and an email service? All of a sudden, things get really complicated, with every tool speaking a slightly different language. How do you possibly manage all of that?
This is where the Model Context Protocol, or MCP, saves the day. The easiest way to think about MCP is as a universal adapter for all your AI tools. It creates one single standard language for the model to talk to any tool, no matter how that tool was built. It doesn't replace function calling, it just organizes it, making the whole system scalable and way more robust. And with a standard like MCP in place, you can build some incredibly powerful multi-step workflows. An AI can now chain different tools together. For instance, it could check the weather and then use that information to send an email, all in one seamless process. It just makes the whole system cleaner, more reusable, and a heck of a lot easier to scale up.
So we've given our AI a library with RAG, and we've given it a toolkit with function calling and MCP. When we put all of that together, we get something brand new, a truly smart digital assistant. This is what we call an AI agent.
See, an AI agent doesn't just respond to a prompt. It understands a high-level goal. It's less like a chatbot and much more like a junior assistant. You don't give it step-by-step instructions, you just give it an objective, and it figures out which tools to use and what steps to take to actually get the job done.
And this is where everything we've talked about really comes together. An agent can take a big goal like plan my trip to California and just figure it out on its own. It might use one tool to search for flights, then use its RAG library to check for local events, and then use a third tool to book a hotel. It can handle errors, remember the context, and manage the whole complex task from start to finish. So, we have covered a lot of ground. Let's just do a quick recap of the key building blocks that are taking AI from a simple chatbot to a capable assistant that actually gets things done.
We started with RAG, that's the library, for specialized knowledge. Then we added function calling. Those are the hands to use external tools. We brought some order to that whole toolkit with MCP, our universal adapter. And finally, we combined it all into an AI agent, a system that can plan and execute on its own. Each piece builds so powerfully on the one before it.
And this really is the new paradigm. We are moving away from an AI that just chats with us, and we're entering an era of AI that knows, thinks, and gets things done. An AI that can genuinely understand, reason, and take meaningful action in our world. Which leaves us with one last really exciting question. Now that these foundational building blocks are here, the old limits are just falling away. The question is no longer just, what can AI do, but what will we choose to build with it? Thanks for joining me.